Question number 23, part 1. In each of the reactions below, tell how the equilibrium responds to a decrease in pressure. So, decrease in pressure. The decrease in pressure is the same as an increase in volume. So if we're decreasing pressure, we are also increasing volume. Because as you add more pressure and compress those, or as you're taking away the pressure and the molecules are moving around more freely, they have more space. Also, equilibrium shifts towards the side with a greater number of moles of gas. So, equilibrium shifts to greater number of moles. So we should calculate the number of moles. So look at the coefficients. There is 1 mole here. Let me switch colors. 1 mole here. And then this is 1 mole and 1 mole. So there's 1 mole of CaCO3, 1 mole of CaO, and 1 mole of CO2. And then you add them together. So it's really 2 moles. So it shifts towards the greater number of moles. Therefore, an increase in pressure shifts to the left because there's more moles on the left. It shifts left because there are a greater number of CaO and CO2 moles. And this also means that our K constant decreases. So now we're going to look at part B, which is another example. N2O4 reacts with 2NO2 gas. And this one is very similar because we're still decreasing pressure. So that means we're still going to increase volume. And that also means it's going to shift to the side with more moles. So let's see how many moles we have. This is 1 mole. And then here, because of the coefficient, we have 2 moles. Same as before, just different because you had to add the moles here, the coefficient I already told you. And so with our decrease in pressure and our increase in volume, it's going to again shift left because there are more NO2 there are more NO2 moles than there are N2O4. And then your K constant is going to decrease. Now there is a part 2 to this equation or question, and so I'm going to flip the board around. Okay, so we've got the question of how would a temperature increase affect the following equilibria? Okay, so when our temperature increases, what happens to this equation? So the first thing we're going to look at is the fact that we're given a delta H and that our delta H is negative. When we have a negative delta H, that means that you have a exothermic reaction. If it was a positive delta H, it would be endothermic. What does endothermic mean for this equation? And what does exothermic mean? Since it's exothermic, that means that heat is produced and so that means that heat is a product. And so when you increase the temperature, that is the same as adding heat to the products. And so the system removes the product because we've been working with Le-Chartr's principle of restoring balance for both parts. And his principle is that the system opposes the change to restore equilibrium. So when we are increasing temperature, that means that the system is decreasing, so the system is removing. And that's because of Le-Chartr's principle. And so we can conclude that this is a reverse reaction and that K decreases and equilibrium shifts to the left. And it shifts left because of the way that there's a reverse reaction because your system is decreasing, so it's going to be shifting to your left.